This naturalrefrigerants.com article is being read by an automated voice. Pressure exchanger device for CO2. Refrigeration found to cut energy and water use at stores in US and Europe. By Michael Gary, published November 4th, 2025. Energy Recovery, a San Leandro, California-based component manufacturer, on October 29th released recent operational data from transcritical CO2 refrigeration installations in North American and European supermarkets, showing that its pressure exchanger device can help these systems perform more efficiently in hot climates and reduce water consumption. According to Energy Recovery, the device, the PXG1300, provided up to 15% in annual energy savings, up to a 22% lift in coefficient of performance, COP, and up to 460,000 gallons, 1,741,289 liters in an annual water savings. The installation sites represent varied geographies, climates, and system architectures, including systems with adiabatic gas coolers, parallel compression, and heat reclaim. Results are based on side-by-side testing at multiple sites, comparing system performance with and without the PXG1300 under similar weather and load conditions. The PXG1300 gives operators an edge cutting energy and water use while helping systems perform through demanding heatwave events, said Ricardo Freitas, Vice President of CO2 at Energy Recovery. Energy Recovery marketed its pressure exchanger device for more than 30 years in the desalination industry before introducing it to the supermarket industry for use in transcritical CO2 systems in 2021. In the U.S., the first supermarket to install the device was Vallarta Supermarkets, a California chain. The PXG1300 has now been installed and is running in dozens of sites across 3 continents, according to Energy Recovery. 7-store study. With its announcement, Energy Recovery published a white paper detailing the results of its efficiency study. The study encompassed 3 stores in California and 1 each in Canada, Spain, Hungary, and Belgium. Data collected over the various time periods showed the Canadian store achieved an average daily COP lift of approximately 10%, while the store in Barcelona, Spain, saw up to 16% COP lift, reducing estimated annual energy consumption by over 40 megawatt hours, Energy Recovery said, adding that a site in Budapest saw a 22% COP lift during the summer months. The results over the testing period showed that the PXG1300 reduces compressor workload and power spikes, translating into annualized energy savings that grow with rising ambient temperatures, said Energy Recovery. The technology also enhances resilience during heat waves by increasing cooling capacity and preventing temperature spikes that could jeopardize food safety. The pressure exchanger device is also designed to help operators avoid recurring costs related to water use, treatment, and maintenance in evaporative or adiabatic gas coolers. Eliminating sprayed water during heat waves, a common practice in the EU, helps prevent mineral deposits and scaling on the heat exchange surfaces and pumping circuits, said Energy Recovery. This in turn extends equipment life, reduces service interventions, and lowers overall operating costs. At a grocery store that uses an adiabatic gas cooler in the Sonoran Desert region of California, the PXG1300 saved an estimated around 460,000 gallons, or 46% of water annually, said Energy Recovery. Another California store did not need to turn on its adiabatic system over a period of 18 months, while reducing the CO2 rack's annual energy consumption by 19 megawatt hours. Energy Recovery touted the pressure exchanger's ability to increase the capacity of the refrigeration system during heat waves by enabling compressors to deliver more cooling at their maximum operating point. The device thus can eliminate the need for standby or supplementary compressors that would otherwise only be utilized for a few weeks per year. At the Atmosphere America conference in June, Energy Recovery and OEM Hill Phoenix showed that the PXG1300 pressure exchanger in a transcritical CO2 rack could improve COP by up to 15% in 95 degrees Fahrenheit, 35 degrees Celsius ambient temperatures. Michael Gary is the U.S.-based editor-at-large for Atmosphere, where he was previously editor-in-chief of the naturalrefrigerants.com website. He has worked at Atmosphere since 2014 and has covered natural refrigerants since 2006.